This is a Farm Doc Daily webinar. I'm your host, University of Illinois Extension's Todd Gleason. Our thanks to Jim Maltz behind the scene. And today we'll be taking up the economics of adopting weeding robots with Shadi Atallah. Thank you for being with us, Shadi. He is with the Center for Digital Agriculture. It doesn't say so, but I assume that you are in ABE, or Agricultural and Biological Engineering. Is that correct?
I am actually with Agricultural and Consumer Economics.
You're with ACE, even better. Well, even better. I like the Economist. So it didn't say where you were from, and I forgot to ask that ahead of time. Well, fantastic. So we're going to get started. I'm going to turn things over to you. You'll take off for the next 25 minutes or so. Thank you.
Thank you. Thank you for the introduction. Yeah, so I think we're supposed to be having an ACES identity going forward. That's why we have the ACES logo. Hi, everyone. My name is Shadi Atallah. I am an agricultural and natural resource economist in the Department of Agricultural and Consumer Economics in the College of ACES. And this is joint work with my colleague, Professor Madhu Khanna, and our former PhD student, Chengzheng Yu, who's now an assistant professor, and our postdocs, Linghui Wu and Saurajyoti Kar. And this is interdisciplinary work, and so it only makes sense that we also have people from ecology, and this is our colleague here, Muthukumar Bagavathiannan, and our colleague from computer science and ag and biological engineering, Girish Chowdhary. And we will be talking about the economics of adopting weeding robots. So the problem, let's focus on the problem that you heard about in the introduction. The problem is that not only do we need to control weeds, but we also need to control for resistance of weeds. This is in the context where more than 93% of the planted acres on the row crops in the US are planted with genetically modified herbicide-resistant crops, which has been very useful for productivity and for the simplicity of weed management, but that also has led to relying exclusively on herbicides for weed control. And as you heard in the introduction, when we do that, it's not a matter of whether, it's a matter of when resistance is going to develop. And so we have seen that since the 1970s. We have seen what sometimes is referred to as super weeds. These are herbicide-resistant weeds rapidly showing up all over the landscape as a result of this use of this rather just one method of weed management, as opposed to using a collective of methods. So that means that the herbicides that have been used have been seeing their efficacy declining over time. And as you heard in the introduction, that's in a situation where there's nothing in the pipeline in terms of new modes of actions that are going to give us solutions to that problem the way we have seen it. And some studies have shown that if we don't have any alternative and we keep losing the efficacy of chemical control, that's going to lead to crop losses that can reach up to $100 billion per year unless we find alternatives. So enough with the problem. Let's move on now to the solution, or the potential solution, because this is a technology that is in development. So what you are seeing here is a nice illustration of what we call these small semi-autonomous robots that can be used for multiple functions on the farm. And today we are focusing on one of their uses, which is the robotic weed control. And so given that we're discussing that as an alternative to chemical control, so these are going to be mechanically removing the weeds. So we're not talking, because there are other robots that will spray, but that will not solve the issue of resistance. So we're talking here about these robots that will be able to conduct mechanical weed removal, and they use AI for navigation and for automation. So they are going to be able to navigate under the canopy of corn, and they are going to be able to detect the weeds and mechanically remove them. That's a great solution for us, because we know that when it comes to herbicide resistance or resistance in general, what we need to do is to use less of what's causing that resistance. So in that case, the chemicals, so this is mechanical, so that's going to be environmentally friendly. It will be high, it will have a high efficiency, and depending on the context, it might solve a problem of availability of labor. This is a very short video for you to have an idea of how it works. It's not necessarily the right season when this video was taken, but you could see this is a robot that is very powerful, that can have a certain level of autonomy. It has a hoe that is mechanically mechanically not allowing the seeds of weeds to emerge. And you can imagine how this would be developed to become more sophisticated, with maybe arms that are able to pull out differently than what you are seeing here. But this is to give you an idea of how small it is, and how autonomous it is, and also how it's not using spraying, right? This is purely mechanical weeding. Now, we were interested as economists in understanding, as farmers will be faced with this decision to adopt robots with or without using also herbicides, what are some of the considerations that they needed to consider? So there are around 4 family of considerations that one needs to think about. The first one is the technological attribute. So this is coming from the robotics side. One might wonder how autonomous is this robot, and whether that matters for my adoption, right? So you could have the fully autonomous robot that does everything without any human supervision, but you could have intermediary levels of adoption, which means that somebody on the farm might need to walk with the robot in case it tips over, and if it's not fully automated, let's say, to be able to get back on its wheels. If I'm buying the robot as opposed to leasing it, then I might want to think about these maintenance costs for these different levels of autonomy. I might be concerned about the speed at which it travels and it is able to cover my fields. When we did focus group with corn farmers, that's one question that came up. And most importantly, it's the efficacy with which they eliminate weeds relatively to what we have known, which is the chemical control methods. The second set of factors, of course, are the economic factors. The crop prices, herbicide costs, robot prices, and labor costs. So if you are in a farming context, the higher the crop prices, you would imagine, the higher potentially the incentive to adopt them, the more expensive or less efficacious the herbicides, the more likely I am to adopt the robots. The prices, of course, matter. And if this is a context where a robot is replacing labor, this is not necessarily the case here with corn in the Midwest, but you could imagine other applications, then of course labor costs will also matter. Now, importantly, this is why we needed to work with a weed ecologist here. The biophysical conditions of the farm also matter, depending on the weed density on the farm, but also the level of resistance on the farm. That is going to affect whether I want to adopt the robots, how early I want to adopt them. And the weed ecology here matters a lot, because this is not a yearly decision that only has yearly consequences, because the seeds are contributing to the seed bank of the weeds. And so my weed management today will not only affect my profits today and the losses that I'm trying to avoid today through weed management, but also they will affect the seed bank and therefore the future weediness and resistance and profits in the future. So this is why it's important to account for these dynamics that link my decisions today with outcomes in the future. And that is related to this idea of also we have to recognize that there might be different weed management types on the farm, depending on whether weed management is accounting only for year-to-year decisions and outcomes. We're going to call that's an economic jargon that uses the term myopic management to represent a situation where a manager does not or cannot take weed and resistance dynamics into consideration. That could be because they don't know what's going to happen to the ecological dynamics, or because maybe they because of whether they are tenants or owners, that matters to how long their time horizon is. And we are going to compare that with a situation where the manager knows about weed resistance and its impact on the future, and they will take that into consideration. So we're going to call that forward-looking. So you'll hear a lot about myopic versus forward-looking management. Sometimes we're going to refer to that as short-term versus long-term. But this is what this is about here, because we're dealing with a dynamic problem. And dynamic means that my decisions today affect outcomes in the future. And then the final set here is, if we put all of these questions together, is these are the 4 different types of consideration one has to take into account. And then the questions that we want to ask is, well, without doing any type of economic analysis that requires models of profit maximization, we wanted first to know whether farmers are willing to adopt weeding robots. So that's the first question we wanted to ask. And we answered that using a survey. So this is not going to tell us about whether this is the optimal decision, but this is going to tell us what farmers are telling us about what they would do with such technology. And I'll talk a little bit more about that. And then there are the last 3 questions. For those, we could not use a survey to answer these questions, but instead we needed to do ecological economic modeling with robotics to answer these questions. And these are what conditions on my farm and conditions around the technology will trigger my moving away from herbicides to adopting the robots. And if I do that, the third question here is, how should I optimally adopt them? How many of them? Should I deploy them on all of my land, or should is it going to be a percentage relative to herbicides? And the timing, when, if they're available today on the market, should I just go and adopt them right away, or is it going to be a situation where I might wait until resistance is way worse and then I will adopt them later? And then finally, this all will converge to the one metric that the 2 metrics that we care about: profits, how will adoption affect profits, and weed resistance development. So these are the questions. So we started with the problem, the potential solutions, and then these are the questions we ask in this research. And then we can move on now to the answers that we got from our research to these questions. The first one was, will corn farmers in the Midwest adopt weeding robots once they become commercially available? And so to that end, we conducted a choice experiment survey with randomly selected 251 corn farmers in 12 Midwestern states. And let me tell you a little bit more about what a choice experiment is. So this is different from a survey where you ask people, hey, are you willing to adopt, yes or no? But instead, we give respondents different profiles of the robot that have different prices associated with them, different efficacy at conducting the weeding of removal of the weeds. So all of these characteristics that I mentioned earlier. And that's important because it mimics the decision in the marketplace where the purchasing decision about a product that has different attributes. So that's what we refer to as a choice experiment. And so in that survey, and you're seeing on the map the dots that represent the magnitude of how many people responded to that survey. If you are wondering if it's representative of where you are, we find that more than half of farmers said that yes, I would adopt a weeding robot. So this is just a snapshot of whether they would adopt or not. However, the more important part, given that we give them different characteristics of the robots and they are sequentially making decisions in the survey, they're simulating as if they're purchasing a robot in the survey that they have different alternatives. As they make those decisions, we are able to tell what increases the likelihood of adoption of the robot among these characteristics, what characteristics they don't care about, and what characteristics will act as a barrier to the adoption. And so let's focus here on the 2 characteristics of the robot, or the situation where they are, that will make them more willing to adopt the robot. The first one, of course, you would expect that if a robot has a higher effectiveness at reducing the weed, that is going to increase the likelihood of adoption. This is no surprise there. But the more interesting part is that we are able to attach a dollar value to that. So we'll talk about that in a moment. And the second factor that matters a lot is farmers who currently face a higher degree of weed resistance are the ones who are more likely to adopt the robotic weed management. So this is really important because it's telling us that the development of that technology and its goal is consistent with what farmers are demanding and what they are interested in a solution to weed resistance. Now, in terms of the situation where they are that will make them less willing to adopt robotic weed management, we find that farmers who currently have neighbors that have a lot of weeds, so very weedy neighboring farms, that made them less willing to adopt the robot. And this could have gone either way, right? If I think that I'm surrounded by a lot of weeds, maybe that made me more likely to adopt because now I have this technology that I want to use as a self-protection, but that's not what we find. We find actually that if I have neighbors who do not control their weeds as well as I do, that's going to discourage me from adopting the robot. And I mentioned that in one of the focus groups, a lot of farmers were concerned about how long is it going to take to cover my fields, basically how many passes does it need. In this larger survey, we found that this is not a factor, and that kind of makes sense because if you're achieving a certain effectiveness and you know the cost, maybe you're not too worried about the number of passes needed. Now let's move from the same survey results now to the monetization of these survey results. So in a choice experiment survey, because there are prices attached to these choices that farmers are making in the survey, we are able to estimate the willingness to pay, not only for the technology as a whole, but for small changes in the characteristics of that technology. And that's important because then we can communicate that to the technology developers so they know what is the value for small changes in the characteristics of the technology or changes in the environment where that decision is being made. So the first finding here is that farmers are willing to pay $25 per acre for every 1 percentage point increase in the proportion of their crops that is affected by herbicide-resistant weeds. So what that means is that if you have two farmers one with higher level of herbicide resistance, just 1 percentage point higher, that's going to increase their willingness to pay for that robot by $25 per acre. So that's the monetization of that, the factor of how much resistance do I have on my farm. The second one had to do with what my neighbors are doing. Remember, that was a discouraging factor. And so the way to interpret that is that if I have less neighbors that have a lot of weeds, that's going to increase my willingness to pay by $23 per acre for every 1 percentage point of decrease in the neighborhood. So then this is just a way to monetize how having neighbors that are cleaner increases my willingness to pay for the technology. And not surprisingly, for every 1 percentage point increase in the effectiveness of the robotic technology, farmers were willing to pay $220 per acre. So moving on now to the set of questions that we are not able to answer in a survey because they require this thinking across multiple periods because of the seed bank, etc. And so here our question is, how should farmers adopt the robot? This is not a yes/no question and not a yes/no answer that we can have because of the intertemporal dynamics of the problem. So the set of questions we ask here is, when should farmers adopt the robot in terms of the thresholds that they have of number of weeds and resistant weeds? Should they just stop right away using the herbicides, or should they combine the two in some optimal percentage? And what are these ecological conditions on my farm that will trigger me to adopt robots? And this is the kinds of questions that we cannot answer in the survey, but it requires a model that integrates farm economics, weed ecological dynamics, and robotics. And this is one of the most exciting parts of doing this research is the need of integrating farm economics with knowledge about weed ecological dynamics and information about the robotics. And so the first finding that we have from that model, so this is a model that is considering two types of management, the ones that I mentioned earlier, the myopic management, the one that says I'm going to manage every year, and I'm not going to consider the future. And then the other type of management, which is the forward-looking. So we're looking here at the weed management that does not account for seed and resistant dynamics. So maybe I cannot do it because I'm only managing for 1 year or 2 years. So we are looking here at this graph that tells me on my farm, if I go and I sample the soil, how much, what is the density of wheat seed? You're seeing that on the x-axis. And how many of these wheat seeds are resistant to the herbicide. And so what you see here is that if I have few wheat seeds and very few of them are resistant, then I have no economic incentive to adopt the robot. And that makes a lot of sense. And that's to the left corner here at the bottom. And then as wheat density increases on my farm and resistance increases, this is when I'm moving to the region of these two parameters under which I adopt robots from an economic optimization standpoint. And we look at two situations here, a $40,000 robot and a $20,000 robot. And as you would imagine, the more expensive the robot, the more I'm going to wait until I have more weeds and more resistance until I adopt the robot. So what this result is telling us is the ecological conditions of my farm in terms of the weed seeds and resistance, how those trigger my adoption. These are the values that you are seeing on the X and the Y axis. So this is the weed management that does not account for the future. Now, if you look at the weed management that does account for the future, then you will see here that weed seed density does not matter anymore. Why? Because even if if I have very few seeds, if I'm accounting for the future, I know that are going to be problematic. So I'm going to trigger my adoption regardless of that, and I'm only going to consider resistance level. And if we compare these two graphs side by side, you will see how much lower the resistance level needs to be on the right-hand side if I'm managing for the future to trigger my adoption relative to the values that you're seeing on the y-axis to the left-hand side. So what that means is that if I'm managing for the future, even if I find super low quantity of resistance on my farm, then I should go ahead and adopt the robots. And again, it changes based on the price of the robots. The third question was, yes, fine, I will adopt the robot, but tell me when I should adopt them and how many, and whether I should adopt them all over my field. So what you are looking here at the right-hand side, so the orange is the myopic or short-term management, and blue is forward-looking. We're looking at the proportion of the land that will be covered by robotic weed management on the top, and at the bottom, you're looking at the number of robots that I will need per acre. What you see here is that if I'm managing in a short-term fashion, I will not adopt the robots until around year 6. And this is when the herbicides are not effective at all. And this is when I will stop using the herbicides altogether, and I will shift to adopting only the robots. But that's because I waited until the resistance got really bad. So I go from 0% robot to 100% robot if I'm doing myopic management. And that's reflected here. I go from 0 adoption to full adoption. That's the maximum here is 6 robots per acre. However, if I'm managing for the future, if you see here, I will start adopting the robots earlier in time. And because I do that, then I will adopt fewer of them eventually. And I will never reach a situation where I'm treating all of my field with robots, and that's because I'm mixing robotic use and herbicides throughout. I'm not depleting the efficacy of my herbicide and then introducing the robot. Instead, I'm using them together. So you look here at the forward-looking management. Eventually, it's 75% robotic use, but 25% of the land is still used. It's still using herbicides. And that's because I saved the efficacy of my herbicide for the future by combining herbicides and robots. And so the results of that, so these are the same that we saw earlier. Now I'm just adding the profits to the right-hand side and the resistance dynamics. As a result of that, overall the time horizon, the forward-looking management is going to achieve higher profits. So initially it's going to have lower profits because it's investing in the robots earlier on, but you can see how eventually it's going to lead to higher profits. And that is going to lead to much lower resistance dynamics under long-term management relative to short-term management that says, I'm going to wait until resistance is terrible, and then I'm going to introduce the robots to deal with it. And this is a graph that shows, not from an economic optimization perspective, but just from, as a society, if we care about managing resistance, if you look at the y-axis here, it's how long it will take for resistance to develop. You see on the x-axis, the more acreage coverage we have of robotic weeding, the faster we can delay that development of resistance. And you can see that effect is much faster when I go from 75% robotic weeding proportion to 100%. And so to recap the questions and the answers that we had today, will corn farmers adopt weeding robots? Using a survey, we find that yes, more than half said that they would. What conditions of the farm will trigger weeding robot adoption? We find that resistance level is the one that will do it across different management types. How should I adopt it? If I'm looking for the future, then I should adopt earlier so I can use fewer, and I will use them as complements to herbicides, and that will lead to higher profits and lower resistance. If you would like to know more about this research, just last month, this paper got published based on which I discussed these results with you today. This is open access, so you can use that link to access this work. I need to acknowledge that this is work that is funded by USDA NIFA. And before I leave you, I would like to ask those of you who are farmers and interested in nutrient management, we have a survey going on now to understand whether you are interested in adopting novel P and K management practices. And this is the QR code. Oh, I should say that the first 20 will receive a $100 gift card if you participate in our survey. This is the QR code for the survey. So this is going to be similar. We're looking at new technologies and want to understand the willingness to adopt of these technologies. Thank you. This is my email. If anybody has follow-up questions, or if you are not able to access the paper, feel free to contact me.
Well, thank you. That was fantastic. I'm going to run this back to the QR code just to leave it up for a second so everybody can see it. You, of course, have been watching a Farm Doc Daily webinar, this one on robots and weeds. Very, very interesting. I'm wondering, just a quick question. Did you think very much when you were taking the survey about how farmers have made adoption of other things? Because this is both the adoption of technology and mechanics at the same time. And the only thing I could come up with that was relevant in my mind was the adoption of Roundup Ready soybeans, which was a technology, not a mechanics, but something of that source. Farmers adopted in about 3 years, Roundup Ready soybeans across the United States to the 80% level. And when I saw your numbers, it said it took 6 years, and they just went, oh, I'm done. I'm investing directly. I thought that timeline seemed about right to me, and I didn't know whether you had thought about, had looked back when you were putting this survey together to think about how farmers have adapted technology in the past. It just made some sense to me.
Well, it's great to hear that it made sense in the example you bring up. We did not think about that example. It did not motivate the results that we found. So I'm glad that's a sort of validation. But we do ask farmers in every survey, what is it that they have done so far to deal with that problem? And so we do know what management practices or adoptions they have made in the past. The results of the survey are not published yet. So this paper is about the model that tells us about the optimization of the adoption, but we can still go back and look at these previous adoptions of other weed management related technologies and see how so from the literature, we know that previous adoption of related technologies increases one's adoption of future ones, conditional on success of that technology, of course. But yeah, that's a good question. We can look at that in the survey data.
We would like to remind everybody that we do have some sponsors here. They include the TIA Center for Farmland Research, CoBank, Compare Financial, Corteva AgriScience, Farm Credit Illinois, Growmark, the Illinois Corn Growers Association, and the Illinois Soybean Association. Our educational partners include the College of Agricultural, Consumer, and Environmental Sciences. That's the College of ACES here on campus, and the Department of Agricultural and Consumer Economics. Sometimes we just call that FarmDoc, or a portion of those folks, the FarmDoc team, and of course, University of Illinois Extension and FBFM. That stands for the Farm Business Farm Management Association. It's the record-keeping association across the Midwest and certainly here in Illinois. Thank you for joining us today. Again, you can find more on this. It will be archived on the FarmDoc Daily website in the archive section at farmdocdaily.illinois.edu, or you can look it up on YouTube at youtube.com/@FarmDoc. On behalf of Shadi Atallah, Jim Baltz, who's behind the scenes, and myself, Todd Gleason, thank you for joining us.